Okay, let's unpack this. Think about your daily financial life.
Mm-hmm.
That credit score dictating if you get a loan, or the fraud detection systems protecting your bank account. These are all powered by incredibly complex financial models
Absolutely.
everywhere.
But for most of us, they operate like total black boxes.
Mm-hmm.
You put data in, you get a decision out,
Yeah.
and the how, well, it just remains a complete mystery.
Right. The inner workings are completely hidden.
So our mission today is really to pull back the curtain on these intricate financial AI models.
Yeah.
And we're going to explore how a truly innovative approach using something called LLM agents is making that possible. It's pretty fascinating stuff.
It really is.
The core problem we're tackling is exactly that. Opacity. These models, they form the backbone of banking and capital markets, right?
They really do. Critical infrastructure.
Yet they're largely incomprehensible to anyone outside a very, very specialized data science team.
And this isn't just, a technical headache. It has profound real-world consequences.
How so? Well, what's fascinating here is that the ability to interpret these models, it's actually becoming a regulatory necessity.
Ah, okay, so compliance is a big driver.
A huge driver. But it's also a fundamental way to reduce business risk, and crucially, it builds trust. Think about it. Imagine trying to explain a complex lending decision to a client.
Yeah, that sounds tough.
Or assure regulators about the fairness of your model, or even helping your own senior management understand why a certain portfolio risk exists. Different audiences need completely tailored explanations.
Right, you can't give the same report to everyone.
Exactly, and they all need continuous assurance that these models are reliable, that they're fair, it's not a one-off check.
Okay, so we have this challenge: opacity, different audience needs, regulatory pressure. But what's the cutting-edge answer here? I've heard whispers about large language model, or LLM agents being the key.
Mm-hmm.
Isn't that just adding another layer of complexity? Like, how does that actually solve the problem of these black boxes? Seems counterintuitive almost.
That's a great question, and that's precisely where the innovation lies. We're looking at a novel paradigm where LLM agents, equipped with something called tool calling capabilities, act as intelligent orchestrators.
Orchestrators.
Yeah.
Okay, like a conductor for an orchestra.
Exactly like that. Imagine them unifying every aspect. The model making a prediction, the explanation for that prediction, and the continuous monitoring of how it's doing.
Okay, so prediction, explanation, monitoring, all brought together.
All brought together. They dynamically generate context-rich explanations tailored to specific stakeholders, your client, your regulator, your CEO, all while maintaining constant oversight. This isn't just a technical upgrade, it's a fundamental power shift.
A power shift. How?
Well, imagine financial models, once sort of held hostage by a handful of data scientists, now becoming truly transparent and accountable to every stakeholder. That fundamental shift in control and trust, that's the real game changer here.
That's a powerful vision. Wow. But before we dive deeper into how these LLM agents actually work their magic, maybe it's worth understanding why our current methods for model explainability often just, well, don't cut it.
Yeah, that's crucial context.
What are the biggest gaps you see with the traditional approaches?
It often boils down to fragmentation and the inherent black box nature of many models we use.
Fragmentation, meaning things are disconnected.
Exactly. Most existing methods, even, advanced ones like S-shape or Lime, which are techniques designed to show what features primarily drove a model's specific prediction.
Right, the why behind a single decision.
Precisely. But they usually offer just a static snapshot, a picture in time. And this snapshot is often disconnected from real-time events, like when the underlying data feeding the model starts to change.
Which happens all the time in finance.
Constantly. That's what we call model drift. The explanation you got yesterday might not be valid today because the data shifted.
Okay, so static explanations versus a dynamic world. That's one issue.
That's a big one. Then there's the audience mismatch we talked about.
Yeah, the different languages.
Right, complex attribution plots, those detailed graphs. They might be great for a data scientist. They love that stuff. But they absolutely alienate a client or a business leader who needs clear, actionable insights, not a deep dive into statistical coefficients. They just want to know what it means for them or the business.
So the communication breaks down.
Completely. And finally, you have governance silos. Explainability, model monitoring, compliance, they often operate in their own little worlds independently.
Silos. Yeah, that sounds risky.
It really is. This separation increases operational risk and it obscures the holistic health of a model. You don't get the full picture.
Hmm.
So bridging these divides requires an architecture where explainability and monitoring aren't just separate features bolted on.
They need to work together.
Exactly. They need to be truly interdependent, continuously updated, and critically audience aware. They need to know who they're talking to.
That makes perfect sense. So if that's the problem, the fragmentation, the static nature, the audience mismatch, what does this new vision, this LLM agent as an orchestrator, actually look like structurally? Can you walk us through the conceptual architecture?
Sure. At its core, you still have your quantitative model, let's say an XGBoost classifier, which is a really powerful type of machine learning model. Very common for things like predicting credit risk.
Okay, the core prediction engine.
Right. Now, surrounding this model, you have a suite of specialized tools. Think of it like a craftsman having different tools in their toolbox for different jobs.
Tools. What kind of tools are we talking about?
Well, the LLM agent's role is to act as the intelligent orchestrator, invoking these tools contextually when needed. So first you have a prediction tool. Pretty straightforward. It just generates the scores or labels from the, approved or denied or risk score.
Got it. Gets the answer.
Then an explanation tool. This is often a SHAP-based explainer or something similar to determine the local feature attributions.
So the why tool. Why this prediction?
Exactly why the specific prediction was made. And then really crucially, a monitoring tool. This is for real-time data drift detection.
Alarm system you mentioned.
Precisely. Using statistical tests like KS or PSI, these are like highly sensitive alarms telling you when the underlying data starts to behave unexpectedly, starts diverging from what the model was originally trained on.
Which could make the model unreliable.
Hugely unreliable. This monitoring tool also checks for consistent behavior across different groups or outcomes fair, and it tracks rolling performance metrics like AUC, which is a common measure of how well a classification model is actually performing over time.
Okay, so prediction, explanation, and constant monitoring tools, and the LLM
Yes.
agent calls these.
It dynamically calls these tools based on the situation and the request. And then this is the clever part. It composes comprehensive multimodal explanations. It weaves the information together.
Multimodal, meaning text, maybe graphs.
Exactly. Text, graphs, summaries, whatever is needed. And crucially, these explanations are tailor-made to specific stakeholder requirements.
So this is where it really comes to life for you, the listener, in the form of that stakeholder-centric output.
That's the goal.
So for a client, maybe someone who got denied a loan, you're not getting some confusing, jargon-filled graph.
Definitely not.
You get maybe a succinct, easy-to-understand narrative, highlighting the key reasons, perhaps with actionable recommendations, like improve your credit utilization ratio.
That's exactly the idea. Clear, simple, helpful.
Okay, but then for regulators, it's got to be totally different.
Completely different. They need the nitty-gritty. They'll see granular audit trails, comprehensive model metadata, rigorously formatted compliance documentation. Everything needs to be traceable, verifiable.
Makes sense.
Yeah.
And for executives, what do they see?
Think dynamic KPI dashboards. Key performance indicators. These dashboards seamlessly integrate performance metrics, alerts about data shifts or drift, and insights into how the model is performing across various segments, like different customer groups.
So they get a high-level overview of health and risk.
Exactly. It enables truly data-driven governance at the highest level. They can see if things are working as expected, or if there's a problem brewing.
Yeah, that shift is huge.
It really is. This whole design transforms explainability from being just a one-off post-mortem, a look back at what happened after the fact.
Right, like an autopsy report.
Kind of. It turns it into a continuously evolving governance interface. It's alive, adapting, a profound shift in how models are managed and understood.
And that idea of continuously evolving leads perfectly into our next point, because especially in finance, this continuous oversight, it's absolutely critical, isn't it?
Oh, absolutely critical. Non-negotiable, really.
Why is that real-time assessment so vital?
It's non-negotiable because data distributions and regulatory expectations can shift at lightning speed. Seriously, things change fast. A model trained on last year's data or even last quarter's data might behave very differently today.
Because the economic climate changed? Or customer behavior shifted?
All of the above. And that's exactly what these LLM agents, through their monitoring tools, are designed to handle. They embed these key monitoring functionalities right into the workflow.
So like that robust data drift detection you mentioned.
Yes, using those statistical tests like KS and PSI on feature distributions, constantly comparing them to the training baselines to see if anything looks weird.
Catching problems early.
That's the key. They also perform crucial checks for consistent group-level performance. Looking at how models behave for different demographic groups, examining acceptance rates, maybe disparate impact ratios, other metrics, essentially trying to ensure equitable outcomes.
Which is huge for fairness and regulation.
Absolutely huge.
Yeah.
And of course, standard performance tracking, analyzing time-windowed metrics like AUC, accuracy, calibration, just making sure the model's predictive power actually remains high over time. Is it still doing its job well?
Okay, so the agent is constantly running these checks via its tools. Then what? Does it just generate tons of alerts?
Well, it synthesizes all these complex diagnostics into comprehensible reports, not just raw data dumps.
Ah, okay. It interprets the monitoring results too.
Right. And these reports can be delivered on demand. Maybe an analyst asks, how's the credit model doing? Or via automated alerts if a critical threshold is breached. It essentially transforms what used to be static explainability, maybe done once a quarter,
If you're lucky.
into an interactive control plane for you, the user or stakeholder. You can query it, get alerts, understand what's happening now.
That vision sounds incredibly powerful, transformative even. But as we both know, implementing anything cutting edge, especially in finance, with all its regulations and legacy systems, it comes with monumental hurdles.
Oh, absolutely. It's not plug and play.
What are the toughest real-world challenges companies face trying to put something like this into practice? And maybe what's one crucial best practice that really separates success from failure here?
Yeah, you definitely hit on it. The real world is messy. There are quite a few major challenges. First off, data quality and feature management is just paramount. You can't get around it.
Garbage in, garbage out still applies.
More than ever. Financial data sets are notoriously inconsistent, complex, they change. A key best practice here is having rigorous validation pipelines for your data before it even hits the model or the agent, and version-controlled feature lineage, knowing exactly where your data features came from and how they were built, plus automating retraining triggers if the data schema drifts significantly.
So strong data foundations are non-negotiable. What else?
Then there's tool integration complexity. Getting all these different tools, the prediction system, the SHAP explainer, the drift detectors to talk to each other, and the LLM agent smoothly, that's hard.
Yeah, integrating different software is always a headache.
It really is. The best practice involves using strict API contracts, often with standardized data formats like JSON schemas, so everyone speaks the same language. Also, using containerization packaging software neatly helps a lot. And you absolutely need robust error handling and crucial fallback mechanisms built into the LLM agent. What happens if the explanation tool fails? The agent needs a plan B.
Okay, solid engineering required. What about speed?
Right.
Finance often needs fast answers.
Right. Latency and real-time constraints are a big one. Explainability, especially some methods, can be computationally intensive. It takes time and processing power.
So you might not get an instant explanation for a credit decision.
You might not get the full deep explanation instantly. So best practices include things like caching common explanations to reuse them quickly, using approximate, faster attribution methods when the system is under heavy load, and designing asynchronous workflows. Maybe you give a quick initial decision and the richer explanation follows up shortly after.
Balancing speed and depth. Makes sense.
Then, what about maintaining explainability under model updates? Models get retrained frequently in finance.
Right. As the data drifts, you update the model.
Exactly. But that risks invalidating all your previous explanations and monitoring setups. So the best practice is rigorous versioning, version your models, version your explanations alongside them, perform sanity checks on feature importance every time you update a model did something wildly unexpected change, and automatically adjust your monitoring thresholds for the new model version.
So tight version control is key.
Absolutely. Then there's detecting and addressing group-level discrepancies, the fairness aspect. This is really tricky. It requires a multi-metric approach, especially when potential biases might intersect across various attributes.
Like not just looking at gender, but age and gender or location and income.
Precisely. Intersectional analysis. The solution involves embedding constraints into the model's training process to actively promote consistent outcomes. But technology alone isn't enough here. You absolutely need to involve human domain experts and compliance officers in defining what consistent or fair actually means for that specific context and deciding how to remediate any discrepancies found.
So a human-AI collaboration for fairness.
Definitely. And related to that is regulatory compliance and auditability. We mentioned regulators. Well, detailed logging is mandatory. You need proof.
An audit trail.
A robust one. Best practice is cryptographically secure audit trails like tamper-proof digital records, and automated generation of regulatory reports showing model lineage, explanation snapshots, monitoring summaries, making compliance easier.
Automation helps manage the burden.
It has to. And of course, maybe the most critical, security and privacy considerations. We're talking of highly sensitive financial data. Protecting it is paramount.
Can't have customer data leaking out.
Absolutely not. This means things like anonymization or tokenization of data before it even interacts with an LLM, especially if it's a cloud-based one. Deploying these systems on premises or in compliant private clouds. Implementing strict role-based access control. And ensuring end-to-end encrypted communications between all the components. Security has to be baked in from the start.
Foundational.
Foundational. And one last one, human in the loop and feedback integration. Even with all this tech, you need humans involved. You need mechanisms for stakeholders, analysts, compliance officers, even customers sometimes to flag suspicious behavior or provide feedback on the explanations. This explanation doesn't make sense to me.
So the system can learn and improve.
Exactly. The best practice involves using continual learning paradigms to refine the agent's outputs based on this feedback, and also being transparent about the system's limitations, communicating any uncertainties in the explanations clearly to the users. Don't pretend it's perfect.
Wow, okay. That's a comprehensive list of challenges. It really does sound like a potential minefield to navigate.
It requires careful planning and execution, for sure.
To maybe make this a bit more concrete for you listening, could we give a quick, tangible example of how this might look in practice, even conceptually?
Yeah, absolutely. Imagine maybe a Python demonstration. You could use a framework like DSPy, which is specifically designed for programming with language models, kind of building these agent workflows, and maybe connect it to a powerful LLM like Google's Gemini.
Okay, so Python, DSPy, Gemini.
The core idea there would be simple, yet powerful. You'd expose the prediction function, the explanation function, maybe using SHAP, and the monitoring functions, like drift detection, as simple tools that the LLM agent can call.
So the LLM sees predict, explain, check drift tools.
Exactly. Then, based on a user's request, like explain why loan application 123 was denied and check for recent data drift, the LLM agent dynamically invokes these tools in sequence. It gets the prediction, calls the explainer, calls the drift checker, and then...
It synthesizes the output.
Right. It synthesizes the results into a stakeholder-specific narrative. It orchestrates that whole complex explainability workflow on the fly. It's a way to see the concept in action, showing its practical power beyond just theory.
That helps visualize it. Thanks.
Yes.
Now, this entire discussion, all these components, it really points to a broader impact, doesn't it? Beyond just technical implementation, especially with compliance frameworks like the EU AI Act, really driving these changes globally.
Oh, absolutely. You can't talk about this without talking regulation now. Frameworks like the EU AI Act and others emerging are fundamentally changing the requirements.
What are they mandating specifically?
Well, they often mandate documented, human-understandable decision explanations. They require proven monitoring of model drift and potential bias. And they demand transparent lineage and audit trails, knowing how the model was built, how it's performing, and why it makes the decisions it does.
And this LLM agent approach seems well-suited for that.
It seems tailor-made, frankly. LLM agents with tool calling provide a potentially scalable mechanism to meet these complex requirements. But it's not just about ticking compliance boxes.
You mentioned trust earlier.
Exactly. At the same time, these systems can significantly enhance stakeholder trust by democratizing access to truly meaningful model insights. It's about building confidence, real confidence, in the AI systems being used in finance, moving beyond the black box.
So it all comes together then, this fusion of LLM agents with these modular tool ecosystems.
Yeah.
It really isn't just an incremental improvement, is it?
No, I don't think it is.
It sounds like it transforms explainability from, that static report we talked about.
The autopsy report.
Right,
Yeah.
into this dynamic governance layer, something that adapts in real time to shifting data, to new regulatory demands, and to different stakeholder needs.
Precisely. And as financial institutions increasingly rely on AI-driven decisions, and that trend is only accelerating, this kind of approach paves the way for more responsible, more transparent, and ultimately more trustworthy machine learning.
It feels like it truly bridges that gap we started with, the gap from just getting a prediction to achieving genuine comprehension, understanding the why.
That's the core message, moving from prediction to comprehension.
So a final thought maybe for you, the listener, to mull over. What's really fascinating here, I think, is how these agents don't just tell you what an AI model did, but they genuinely help you understand the why. How might this shift in comprehension, this move towards understanding the why, change the way you interact with financial decisions in your own life, or maybe even how you view other complex AI systems you encounter in the future? Something to think about.